Hello everyone. This question has been taken from Irodov Fundamental Equation of Dynamics, question number 104. The question says a body of mass m is thrown straight up with velocity v naught. Find the velocity v dash with which the body comes down if the air drags equals kv square, where k is a constant and v is the velocity of the body. So what is given in the question is body of mass, that is m, initial velocity with which the body is thrown up, that is v naught, air drag force kv square. We are to find the velocity v dash when the body comes back exactly to the same position from where it was thrown up. So this is the diagram for easy understanding. The body is thrown from this point with a velocity v naught. The body will start ascending. The forces acting on the body will be the gravitational force and the drag force, which will always be opposite to the motion of the body. And that drag force is given, it will be equal to kv square, where v is the velocity at that point. So what will happen gradually? The body velocity will decrease and it will come to a rest after reaching to a certain height. That height we should say that it is h. And after that the body will start falling down under the force of gravity. So when it acquires the motion while coming down, it will start experiencing the drag force again, which will be opposite to the motion of the body. Since the v is downwards now while coming down, so drag force will be upwards, that is kv square. So let us solve these questions now. So according to Newton's law of motion in the vertical direction, or let us say like this, that we have taken a position of the body while going up and assuming that at that position, at that location, the velocity of that body was v. So mg will be the force which will be the gravitational force by which the gravity will pull it down, and second force will be k into v square, because v is the velocity, so this will be the drag force. So for this we can write Newton's law of motion, summation of F is equal to mass into acceleration. Mass into acceleration we can further write as dv by dt. So what are the forces acting downward is mg plus kv square. So that will be equal, further we can dv by dt, and that we can multiply displacement ds and divide displacement ds like this. So ds by dt will be your v. And the remaining part will be dv by ds. So what is the intention of changing it to dv by ds? Intention should be, because we are interested first in knowing how much height it will achieve. So height is the displacement. So that is the reason we have brought this equation in the form of dv by ds, so that we can achieve the height to which the body has ascended to finally after coming to rest. So after reshuffling the equations, we will reach to this ds is equal to m into v into dv divided by mg plus kv square 1. Now ds is soft. We will integrate the equation number 1 on both sides and putting the value of displacement. So displacement will be from 0, like from where the body has been thrown up, 0 to h, to which the body has ascended to. On the other side, at s is equal to 0, displacement 0, what was the velocity of the body? The velocity of the body was v naught, by which it was thrown up. And when it ascended to h height, its velocity is 0. So we have put it 0 over here. So upon solving, we will get this h is equal to m by 2k ln 1 plus k v naught square divided by mg. So this equation we will be getting. So now we have h in our hand. Now we will study the motion while the body starts falling down, and ultimately we are to find v dash at the same position while coming down from where the body has been thrown up. So we will write the equation, Newton's law of motion again. Equation for Newton's law of motion. So summation of all the forces will be mass into acceleration. Again, we will do the same thing, m into dv by ds, and we will be converting it to ds because we are in, because we have h now in our hand. So h we can use in this equation, and v in the form of h we will come to know the v dash. So this is the equation. While coming down, mg will be the gravitational force, kv square will be in the opposite direction because it's a drag force and it will be acting opposite to the motion of the body. Simplifying the equation, we will be reaching to this m into v into dv, this equation. Now we will integrate both sides. So v at the top was 0 from where it starts falling down, and v dash is the velocity at the position from where it was thrown up while coming down. ds will be, now we have taken the origin as the top because the v is 0. When the v is 0 means at the top the body has come to rest. The displacement was 0, and when it reaches to v dash velocity, when it acquires this velocity of v dash, the distance covered is h, our displacement covered is h. So we can write like this. So by solving this equation, we'll be getting v dash is equal to v naught divided by this. So this will be our final answer. Hopefully this question, the way it has been solved, is clear to everyone. If any issue in understanding, please write in the comment. I'll come back on that. So basically we have to focus on, so this is more a mathematical problem and understanding the physical part of the motion of the body. Thank you.